Assalamualaikum warahmatullahi wabarakatuh. So welcome back. So let us continue with the work example of a complex power calculation. So suppose there are two loads which is connected in parallel. So load number 1 has 2 kilowatt power factor of 0.75, so leading, and load number 2 has 4 kilowatt power factor of 0.95 lagging. So calculate the power factor of the two loads and the complex power supplied by the source. So we do have load number 1 and load number 2 with its respective value of watt and also power factor. Then the solution, given that load number 1 has a leading power factor, so remember this is a leading power factor, so the power triangle for load number 1 is then shown below. So we do have P1 equal to 2 kilowatt, and so this is a leading power factor. We have negative Q, so negative Q1. Okay, so we do leading, so meaning that P is above S1. Okay, so the leading power factor, we can simply say that PE is actually leading S, okay, by theta angle, by this value. Okay, so by theta this value. Okay, this is how we can understand by the given condition of the power factor, especially when come to the leading or lagging. Okay, then with of course negative Q1. Okay, so this is also mentioned over here, load number 1. Okay, leading again, so leading, so the power factor again 0.75, so 2 kilowatt of P. So theta 1, this is arc cos 0.75, because PF, again, if you go back to the equation, so the provided PF, this is 0.775. Okay, so this is equal to cos theta. Okay, so to get the theta in terms of degree, so you need to arc cos the value of radian. Okay, which is 0.75. So you get the value of degree, theta 1 equal to 41.41. Okay, so from the power triangle, so we get that, so tangent theta 1, so this is equal to Q1 over P1. Okay, so therefore rearrange the equation to get in terms of Q. So we have Q1 equal to P1 theta tangent theta 1. So 2000 is given in the equation. So the angle is just obtained, okay, here 41.41. Okay, so substitute into this value or into this theta, that give us tangent of 41.41. So the value of Q1 is 1764 var. So complex power consumed by load number 1 is S equal to, so remember S, basically we have S equal to P plus, so JQ. Okay, so this is for load number 1, S1 equal to P1 plus JQ1. So we have 200 minus J1764 VA. Okay, var. So negative value here is taken from the fact that our power triangle, which is showing that Q is minus. Again, it's caused by the leading power factor. So don't forget to add a negative, yes, negative sign to the reactive power. And then what about the second load number 2? So this is again given by 0.95 lagging. All right. So lagging, so we can simply say that P is lag behind. So P is lagging behind by theta 2 degree. Okay. So the value of real power P2 equal to 4 kilowatt. This is given in question. So we have plus JQ2 as well as S2. So again, to get the value of angle theta 2, so arc cos 0. Cos, okay, 0.95. So the radian or the power factor given. So you will definitely got 18.195 degree. Then again, from power triangle, so we get tangent theta 2 equal to Q2 over, sorry, P2 over here. Okay. So rearrange in terms of Q2, so we have P2 tangent theta 2. So 4000 watt from the question, and this is we just find out here. Okay, so the final value of Q2 is 1315 var. So complex power consumed by load is S again equal to P plus JQ. Alright, so P2 400 and Q2 is 1315. So remember the unit of S is volt ampere VA. And then what about the sum of complex power consumed by these two loads? Okay, since we have S load, okay, L stands for load, so the total S or the total complex power consumed by these two loads, this is equal to S1 plus S2. So just rewrite the value of S1 and S2, sum up these two together, and you will get in terms of real imaginary, okay, triangle, and also in polar form. Okay, so power triangle for the complex power consumed by the two loads, again for PL, so JQL and SL. So we have over here, this is the SL. All right, so we have the PL over here, which is 6000, as well as Q, as well as QL. Okay, so this is QL. So and this one is actually theta L. Okay, so you can know that the value of Q is actually negative J 449, or you can simply draw it here. Okay, this is the value of PL, so theta L and SL. So power factor of the composite load, so cos theta L. So cos theta L equal to PL over SL. Okay. PL over SS, so 6000 over 6017. So this value equal to 0.997 leading. Okay, so you can see the negative value over here, or you can see the location of PL, which is leading ahead of SL. Okay, or S, this means the condition of operator is now leading. And then by the complex power conservation law, where SL equal to SS. So this is the total complex power consumed by the two loads, and SS is the complex power supplied by the source. So therefore, complex power supplied by the source is SS 6000 minus J 449 VA. So you can simply get from here. All right. So this is SL. So work example number 2, find the total complex power supplied by the source to these three loads. So now we have load number 1, so we have load number 2, as well as load number 3. So we have plus minus Vs as the voltage source 100, 0 degree, and the solution, we start with load number 1. Okay, so S is given by P plus JQ. So we do have only 100 watt with 0 var. Okay, so 0 Q. So we can simply write that S1 equal to 100 plus J0. So volt ampere. So complex power consumed by load number 2, S2 equal to P plus JQ. So both of the element is provided. Okay, here is the Q, this is the watt. So just simply write into this equation 200 plus J, 700 volt ampere. So complex car power consumed by load number 3. So S equal to P plus GQ. So here, okay, you can also pick from here. So this is the P, this is the, so this is the Q. All right, so this is the Q, this is the P of the load number 3. All right, and then total complex power consumed by the loads. So you just as let's say what the symbol or there is no symbol, so I can simply write here as total, for example. Okay, this is S1 plus S2 plus S3, regardless the condition of the circuit, whether they are connected in parallel like this load 2 and load 3, or in series just like this number 1, because we have seen that in the earlier slide or earlier topic, the value of total S is equal the value of this particular in each particular load. Okay, so you just simply sum up the value of total S. In this particular example, it is S1, okay, at load number 1 plus S2 at load number 2 and S3 at load number 3. So this value for 100, 200 plus J to 700, as well as 300 plus J 1500. Okay, so all together put in this equation, and finally you get that the S total is 600 minus J 800, or you may convert a transform into polar form. Okay, and then this is the angle, 53.13, negative sign. Okay, so downward. So this is also negative J 800 or negative Q over here. Okay, the same thing. So P 600 and S equal to 1000. Okay, so this is the S modulus over here is 1000. Okay, we volt ampere. Okay, this is how you plot the triangle power. So exercise, you may try this on your own. A load connector to an AC and CC supply consists of a lamp, load, blah 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 blah. All the value of power, reactive power or the real power are given. So you just follow the same procedure, also the same analysis, in order to get the P total as well as the power factor. Okay. All right. Then power consumed by three-phase loads. Again, so we will continue in the next video, and hopefully we see you later.